Hey everyone, so today we are going to talk about a few more problems on the quantum mechanics based on inner product of and bracket notations, right? So let us start with problem number 36, which says that consider a kit which is defined as psi as with a column vector minus 1 plus I, 3 and 2 plus 3I as the element, and bra which is defined as 6 minus I and 5, right? Now it is asked that what is the value of psi, inner product of psi and phi, right? So you see, it is earlier saying that it is a kit and this is a bra, but here the positions has been changed. The phi, which is a complex Hermitian conjugate of this phi, is now acting as a kit, and the psi, which is a Hermitian conjugate of this, is acting as a bra, right? So now let us solve it. So how, if it is a similar type of problems are asked in the exam, how we will solve it? So you see, this is kit, this is bra. Here it is, whereas here it is bra and it is kit. So to calculate the corresponding bra and kit of each other, you will have to take the Hermitian conjugate. So let us take the Hermitian conjugate of psi and phi. The Hermitian conjugate of psi is, psi Hermitian conjugate is called basically this, is equals to, take the complex Hermitian conjugate, this is a complex number, and you change the row to column to row, right? So it will be going as minus 1 minus I, as I goes to minus I. Now 3 remains unchanged, and this is 2 minus 3i. So this is what you have got, right? Minus 1 minus I, 3, and 2 minus 3i. Now let us go to this one and calculate the kit corresponding to this bra, which is phi equals to Hermitian conjugate of this bra. So what is, so this was a row, now this will become a column with, and the complex numbers will change the sign, right? So this is a column. This goes as 6 minus I goes to I, and this goes to 5. Now let us take the multiplication we have, multiplication of psi and phi. So it is a multiplication of row and columns. Now how the multiplication will take place? Each element of a row will, we know the simple matrix multiplication, this goes to this goes to this, and this goes to this, right? So minus 1 minus I, right? And then 3 and 2 minus 3i. Remember that this kind of problems are very frequently asked in most of the exams, like in sometime in NET, in GATE, in PhD entrance exams, or any sort of exam like JAM is there, or any advanced level physics exam. These questions are usually asked. So you must understand the clear difference between the two, bracket and their relations, right? So let us take this inner product. So it gives you minus of 6 minus of 6i plus 3i, and then 2 minus 3i into 5 multiplied by 5. So it gives you minus 6 minus 6i, minus 6i plus 3i minus 3i, and then 10 minus 15i, right? So just add it. So 15 plus 3 is 18, and minus 6 plus 10 is 4. So how much you are getting? 4 minus 18i. So it's, the inner product will be 4 minus 18i. So real part will be A, if you are taking A plus BI, A minus BI, it is, and complex part will be 18. right? This is a simple problem with a simple solution, straightforward solution. But what it requires is the understanding of what is asked and how to solve it, right? So I hope that this will be helpful for you in solving similar kind of problems related to the bracket and inner products, right? Now this question is asked that what is the Hermitian adjoint of an operator f e cap equals to 1 minus 2ia plus 3a multiplied by 1 plus ia minus 2a cap, where a cap is basically an operator, right? Now, so let us take the calculate the Hermitian adjoint. Right? Remember that operators are matrices in quantum mechanics. So here, how you will take the Hermitian adjoint? Hermitian adjoint of Fa equals to Fa dagger, right? So Fa dagger will give you F star A dagger, right? So let us calculate it. Now remember that when we are taking it, the dagger, 1 minus 2ia plus 3a cap, and then 1 plus ia cap minus 2a cap, right? Now this complete thing is in a bracket and take the dagger. Remember that the product of the two matrices or operators, when their Hermitian conjugate is taken, will exchange, right? So this will come here and it will go this way. So it will be 1, and then the complex numbers will change the value. So 1 minus ia cap minus 2a cap from the dagger. 2a cap dagger, and then this one will be 1 plus 2ia cap dagger plus 3a dagger, right? So this is simple. Just remember the rule. The product is there, the positions will be exchanged. If you are taking a Hermitian conjugate of AB Hermitian conjugate is nothing but B dagger, B A. Remember that, right? So this is the same rule which you are following here. Simple question, very straightforward. If similar type of question is asked anywhere, you will be able to solve it, right? Here, so let us discuss one more problem which is based on commutator. Now it says that evaluate the commutator x, comma h, and h is the Hermitian operator and h is Hamiltonian. Let us solve it. So what does it say? That if h is a Hermitian operator, so it is defined as how it is defined? It is defined as p square by 2m plus vx, right? Now let us calculate this commutator based on this. So it gives you x into p square by 2m plus vx h x xp square by 2m plus x comma x bx, right? This gives you immediately 0, and you know that commutator of quantities which are dependent on same variables is 0, right? Now let us calculate this, then you are left with this commutator. So you just try to solve it. what is x p square by 2m? It gives you 1 by 2m, right? And the commutator of x and p square will give you 2p and x comma p, right? Which is what? I h cut, right? There is a simple formula of commutator of x to the power n p equals to nx to the power n minus 1 I h cut, and it is vice versa. It is x p to the power n gives you n p to the power n minus 1 I h cut, right? So this formula is what we are applying here. It can be simplified by other way also, by taking 1p on the left side, constructing one bracket, and then taking another on the right side to construct another bracket. So this 2 cancels out. You are left with I h cut by m and x comma p, right? Now just calculate it, x comma p is I h cut. So it gives you I h cut multiplied by I h cut divided by m, giving you minus of h cut square divided by m as the value. So you can see how if you have to, if this type of question, which is very important, if it is asked how you can tackle it, you can solve it by using simple method, right? Simple calculations. So, if any problem related to this ever appears in the exam, you will be able to solve it easily if you understand that, right? Now let us come to the problem number 39, which says that consider the state psi, which is defined as 3i phi 1 minus 7i phi 2, right? And the chi, which is minus phi 1 plus 2i phi 2, where phi 1 and phi 2 are orthonormal, right? Then what is psi plus chi? Inner product psi plus chi, right? So let us solve it. So if you look at it very carefully, psi plus chi, what is psi plus chi? First you need to calculate psi plus chi, then you can calculate the Hermitian conjugate of it. So it will make a bra. So this is kit and this is bra, right? So psi plus chi is given. So what is psi plus chi? So psi plus chi is nothing but sum of psi plus sum of chi, right? Which is 3i minus 1 phi 1, right? 3i, phi 1 adds, and phi 2 adds. So minus 7 plus 2, which is minus 5 by phi 2, right? So this is your psi plus chi. Now to calculate this, you also need the Hermitian conjugate of this number, this value, right? Which is psi plus chi, right? So it gives you, now take the Hermitian conjugate. So this is your, so this will be basically a column vector and its complex will be a row. So this gives you minus of 3i minus 1 and phi 1 right, and plus 5 by phi 2, right? Now take the inner product over 2. So its inner product will give you simply this this minus 1 phi 1 sorry right, complete multiplied by 3I minus 1 phi 1 and minus phi by phi 2, right? Now you just take the multiplication. Remember that phi 1 and phi 2 are orthonormal. So phi 1 to phi 1 and phi 2 to phi 2 will survive, the cross term will be 0 if they are orthonormal. So it gives you 3I minus 1 minus 3I minus 1 and 3I minus 1 and this 5I and minus 5I minus 25I square, right? So how much it gives you? 3I and 3I is 9I square with minus, so minus of 9I square and plus 1. A plus B into A minus B, which is A square minus B square, right? Right? This gives you minus, that's 25 and minus 9, I square will give you plus 9. So 25 plus 1 plus 10, so giving you 35 as the answer. Right? So this is your inner product is nothing but a simple calculation is 35. Right? It's just a vector multiplication, just a matrix multiplication. So this is what we have got. These type of problems are usually appear in the usually appear in most of the exams of physics. Like JAM is there and GET is there. Even JEST or TIFR is there. Obviously, the level is a little higher. But this type of problems usually appear there, especially in GET. So those who are appearing for similar exams, they will find it very useful, and they will learn how to tackle this kind of problem from this, right? Here, so let us discuss another interesting problem related to this product of brackets, right? And so this problem, which is a simple problem, and says that consider the states psi 1, which is 2I phi 1 plus phi 2 plus A phi 3 plus 2 phi 4, and psi 2, which is 2 phi 1 minus 3I phi 2 plus 3 phi 3 and minus phi 4. Right? So two states are there, psi 1 and psi 2, which are mix of states phi 1, phi 2, phi 3, 4. Right? Now it is given that phi 1, phi 2, phi 3 and phi 4 are orthonormals, means they are orthogonal to each other with unit norm. Right? Orthonormal kids and A is a constant. The value of A so that psi 1 and psi 2 are orthogonal is what? It is asked that if psi 1 and psi 2 are orthogonal, what is the value of A, which is here. Right? Now, so let us try to find out how we can tackle this type of problem. It is saying that they are orthogonal, right? So when they are orthogonal, it means that their product will be 0, inner product. So psi 2, psi 1 is vanishing, right? So now using this condition, let us try to find what is A, right? So it says psi 2, now psi 1 is this, and psi 2 is this. Now both are kits. Now let us change the psi 2 in bra, or basically in the row. This is column. Both are columns. Now it will change into K with a Hermitian conjugate by taking Hermitian conjugate of it. Right? So it will be what? It will be 2 phi 1 plus 3I phi 2 plus 3 phi 3 minus 5. Right? This is your Hermitian conjugate of psi 2. Now this becomes a kit, bra, and this is your kit, which is 2I phi 1 phi 2 A phi 3 and 2 phi 4. Right? Now remember that. So these are just the matrices, and the elements are phi 1, phi 2, phi 3, and they are obviously the multiplication terms, right? Or multiplied numbers or complex numbers, right? You can say the coefficients. So now let us, as phi 1, phi 2, phi 3, phi 4 are orthonormal, so the no cross term will appear, only the terms with phi 1, phi 1, phi 2, phi 2, phi 3, phi p and phi 4, phi 4 will appear. So you simply multiply 2 multiplied by 2I, giving you 4I phi 1, phi 1, giving you, now they are orthonormal, so it will be giving you 1 plus 3I into 1 phi 2, phi 2. Right? Plus 3A phi 3, phi 3. Right? Minus so this is what we have got. Remember that this is 0. Now just simplify it. So it will give you 4I plus 3I, which is 7I, and 3A minus 2. Is 0. So what does it gives you? It gives you 3A is 2 minus 7I, implying A is nothing but minus 7I plus 2 divided by 3. So let me write answer A as minus of 7I plus 2 divided by 3. Right? So this is how you solve this kind of problem, and this type of problems are usually there in most of the exams of related to PhD entrance or master degree entrance or any entrance of BHU, GNU or any sort of exam is there. Right? So hope you will find it useful. We will come up with more number of problems next time.